friends, in this session we are going to discuss about the subject example in parts of lowering of vapor pressure. So in the previous session we discussed about lowering vapor pressure, and we derived with the formula for lowering of vapor pressure. So in this session we are going to discuss subject example. Now let's write our question and start solving it. So our question is, calculate the vapor pressure lowering caused by the addition of 100 grams of sucrose with the molar mass of 342 grams per mole to 1000 grams of water if the vapor pressure of pure water at 25 degrees Celsius is 23.80 millimeter of mercury. Now this is our question. From here we are saying solution. And then we are going to data given. So in the part of data given, we are given mass of solute, which is sucrose, MS in bracket is equal to 100 grams. We are given a molar mass of solute, which is MRS is equal to 342 grams per mole. We are given mass of solvent, which is MV is equal to 1000 grams. Then we are given vapor pressure of pure solvent P is equal to 23.8 millimeter of Hg. And then also we know molar mass of solvent ambayo ni molar mass ya water inajulikana MRV is equal to 18 gram per mole. Required vapor pressure lowering. Required vapor pressure lowering, which is change in P, is equal to unknown. So from our formula about to derive vapor pressure lowering, change in P divided by P is equal to number of moles of solid divided by number of moles of solid plus number of moles of solvent. Tunatumia hii formula kwa sababu hatujaambiwa solution is very dilute. Kama solution ingekuwa very dilute, number of moles of solid huku chini tungesema inakuwa ni approximately sawa na 0. So huku chini tumeweka number of moles of solvent. So from here number of moles of solid is equal to mass of solid divided by molars. Mass of solid ni ngapi? 100 grams divided by 342 gram per mole. So mass of solid will be equal to 100 gawanya kwa 342, utapata 0.292 moles. Hizo number of moles of solid, but number of moles of solvent tutapata sana mass yake ambayo ni mass ya solvent ilikuwa ni 1000, so ni 1000 grams gawanya kwa 18 gram per mole. Ukigawanya 1000 gawanya kwa 18 utapata 55.556 moles. Tumeweka kwenye 3 decimal places. So from there tutaenda kusolve kwamba change in pressure hapo so from there to solve change in P divided by P is equal to number of moles of solid divided by number of moles of solid plus number of moles of solvent. So change in P itakuwa sawa number of moles of solid divided by number of moles of solid plus number of moles of solvent times pressure P, which is the pure pressure. All data tunazo. So kama data zote tunazo, hapo tunaingiza data, tunakuja tunapata our final answer. So from here change in P itakuwa sawa NS ambayo ni 0.292 gawanya kwa 0.292 then plus 55.556 times pure pressure water ambayo ni 23.8 mm of Hg. From here tapata 0.292 divided by 0.292 plus 55.556 then it will multiply by 23.8. So the final answer change in P will be equal to 0.124 mm of mercury. So tuta conclude kwamba lowering of vapor pressure itakuwa sawasawa na 0.124 mm of Hg. Kwa hiyo don't worry about the notes. Utazipata tu notes, utazipata for free. Kwa don't worry about the notes, hizo utazipata. That is the final answer ambayo utaipata kufikia swali lako la kwanza. So example 1 utapata jibu kama hiyo hapo. So example 1. From there let's move to solve example number 2. Let's move to solve example number 2. So let's write the question. Now this is our question number 2. The vapor pressure of ether with molar mass of 74 is 442. Kwa ukishaona umepewa vapor pressure, maana yake huyu ndio alikuwa solvent. So to discuss lowering of vapor pressure of a solvent. So vapor pressure ilikuwa ni 442 molar mass ile pale. Now if 3 grams of compound A are dissolved in 50 grams of ether at 293 Kelvin, the vapor pressure falls to 426 mm of Hg. That means this is the vapor pressure of pure ether and this is the vapor pressure of solution. Then calculate the molar mass of compound A, assuming that solution of A in ether is very dilute. Now let's start with the solution and then data given. We are given molar mass of solvent, MRV 74 gram per mole. Then we are given vapor pressure of solvent, pure solvent, P itakuwa sawa na 442 mm of Hg. Lakini pia tuna mass of solute, MS sawa na 3 grams. Tuna mass of solvent MV sawa na 50 grams. 3 grams of compound A are dissolved in 50 grams of ether. Ether ndo solvent wetu. So from there also we are given vapor pressure of solution PS 426 mm of Hg. And required molar mass of solute MRS. Now from this data tumeambiwa kwamba assuming that solution of A in ether is very dilute. So tunasema since the solution is very dilute, au mwingine angeweza kusema for a very dilute solution, then P minus PS divided by P is equal to number of moles of solute divided by number of moles of solvent. For a very dilute solution, formula inakuwa hii hapa. Or you can say P minus PS divided by P is equal to mass of solute, molar mass of solvent, then molar mass of solute, mass of solvent. Now from this equation, we can make subject molar mass of solute. So let's make subject the molar mass of solute, and let's see how we can get the molar mass. We can get the molar mass of solute. So making the subject molar mass of solute kutoka hapa, wale ambao ni wahesabu mtakuwa mnajua, ndio maana tunasoma BAM. So hiyo ina derivation molar mass of solute itakuwa sana mass of solute, molar mass of solvent. Hii P itapanda kule pressure, hiyo P nyingine itashuka chini, P minus PS, then kule chini tabakia tuna mass of solvent. So from there, substituting the data, tutapata mass of solute in 3 grams times molar mass of solvent in 74 times pressure P 442 divided by 442 kutoa 426 multiplied by mass of solvent which is 50 grams. So solving this calculation hapo 3 mara 74 mara 442 hapo taganya kwa 442 taganya kwa 442 kutoa 426 times 50. So the final answer itakuwa ni 122.655. This will be the molar mass of solute. But because this is the molar mass, somebody can approximate to 122.66. All of these are the correct answer. Then it is gram per mole. Gram per mole if it is the molar mass. But if you are writing it as the molecular mass, there is no such much need to write a gram per mole. So this is the answer for question 2. Let I left it for a while if you want to record it. But all these calculations, just go to your notes in the year. So let's move to solve example number 3. Let's write the question. So in this question, we are told 18 grams of urea is dissolved in 100 grams of water at 50 degrees centigrade. Then the lowering of vapor pressure produces 5 mm of mercury. Calculate the molar mass of urea if the vapor pressure of water at 50 is this one. Now solution, data given. In the part of data given, we are given mass of solid, mass of solute 18.2 gram. Then you are given mass of solvent 100 grams. Then you are given lowering of vapor pressure, change in P, which is equal to 5 millimeter of mercury, and also you are given the vapor pressure of pure water, vapor pressure of pure water ambayo tumepewa P ni sawasawa na 92 mm of Hg. So hizo ndo measurement ambazo tumepewa kwenye hiyo swali, na tunahitajika kutafuta the molar mass of urea. So from here required molar mass of solvent, molar mass of solute, MRS. Kwa hiyo ili swali ni tofauti na ile la pili, kwa sababu hili hatujaambiwa the solution is very dilute. Kwa kama hatujaambiwa the solution is very dilute, tunatumia formula ambayo change in P, tunasema from change in P divided by P is equal to number of moles of solid divided by number of moles of solid plus number of moles of solvent. Now, one thing we need to do here is to make the subject number of moles of solid. Now, how do we do this? Mathematics must be applicable. Kwa hiyo tunarudi kwenye sample form 2, making the subject of the formula. Kwa hiyo tuna make subject NS, we will have change in P, NS plus NV is equal to NSP. From there, we will say change in P, NS plus change in P, NV is equal to NSP. Manake hiyo change in P tumemultiply hapo ndani. So tutakachokipata hapo tutasema change in P and S, then let I take this to the right and then left this change in P and V to the left. So it will be change in P and V is equal to change in P, is equal to NS P minus change in P and S. That is to say, change in P and V is equal to NS P minus change in P. To factor out NS. So NS will be equal to change in P and V divided by P minus change in P. So hii ndio equation ambayo itatusaidia kupata NS, ya number of moles of solid. But as we know, nitafuta hapa ili kwamba data zibakie. So nitafuta hii hapa data tuendelee kwa nazo. So as we know, but So but number of moles of solvent ni sawa sana mass of solvent ambayo ilikuwa ni 100 gram gawanya kwa molar mass of solvent ambayo ni 18 gram per mole. So tutapata ngapi? 100 gawanya 18, 100 ya 18 tutapata ni 5.556 moles. So taking this, inserting into that equation, and S will be equal to change in V, that's the lowering of vapor pressure is equal to 5 times NV, which is 5.556 divided by P, ambayo ni pressure ya pure water, 92 minus change in P, which is 5. So tukidivide hapo tutapata jibu 5 times 5.556 divided by 92 minus 5. That means tutakuja kupata it is 0.319 moles. 0.319 moles. From there, as we know, from there tunasema kwamba from number of moles is equal to mass of substance, in our case is solute, divided by molar mass of solute. Molar mass of solute. This is for our case. So we'll calculate the molar mass of solute by simply making the subject. So tutapata molar mass of solute is equal to mass of solute, which is 18 milligrams divided by number of moles, 0.319 moles. So you get mass of solute itakuwa sana 18.2 gawanya kwa 0.319 tapata ni 57.05 gram per mole. That is the molar mass of urea. So therefore, molar mass of urea is 57.05 gram per mole. Hiyo ndio molar mass ya urea in our case, the molar mass of urea ni hapo. Kwa hiyo hivyo ndivyo ambao vitu vinakuwa vinaenda kwa namna hiyo hapo. From there kuna swali jingine hapa ambalo ni la 4. So in this question number 4, ngoja tuione. So tuna swali la 4. Swali la 4 A ni state root slow flowing of vapor pressure ambao tuli state. Kwa hiyo I will not simply state this kwa sababu iko kwenye notes, ila nitaandika B ambayo ni swali la calculation. Nitaandika B Now, this question number 4, vapor pressure of pure water at 25 degrees Celsius. This one, the vapor pressure of solution of 4 grams of sugar in 100 grams of water at the same temperature is here. What the relative molecular mass of sugar. So, hili swali linafanana na hilo ambalo tumetoka kusolve. You need to find the number of moles of sugar, because in our case hatujaambiwa if the solution is very dilute. So kama hatujaambiwa the solution is very dilute, that means kama solution is so dilute, we are using the formula that change in P divided by P is equal to number of moles of solute divided by number of moles of solute plus number of moles of solvent. From there, tuna calculate number of moles of solute by making the subject, and after calculating the number of moles of solute, finally we go to find the molar mass of our sugar. Now it is 100, similar to the question which we have already solved in the previous example. So I left this question at the quiz to you. The answer for this question is 174.8.68. This is the answer of the question. So unatakiwa usolve, make sure unafika hapa. If the answer is not this one, that means you are wrong. But also this is just for the sake of exercising. But if you are lazy, you just go to look for the solution of this question in the notes. But if you want to exercise, it will be best. It will be best. You will be equipped yourself. And if you got any stuck, you don't understand anything, you can just contact me through either my Telegram and my WhatsApp, or through any way which you know. Kwa hiyo hii ni kwa ajili ya kufanya mazoezi. The best way to contact me is through Telegram. You can contact me, and then after contacting me, you can get the solution, or you can get instruction where you did a mistake, or you can submit this question to me. This marks the end of our discussion regarding the solved examples in lowering vapor pressure. In the next session, we will start discussing about the boiling point elevation and the second collegative property, which we'll discuss in our series of discussions regarding collegative properties. So later, I wish you nice studies. I hope you've enjoyed the session, and I hope you'll enjoy other sessions which are coming after this session. Thank you, everybody.